Okay. Okay, my dear students, now we will be moving towards sound waves, and I just want to finish at least its first page till here because very important, and then we can solve many questions and I can give you handsome amount of homework also. Okay, sound waves. As we discussed before, there are types of mechanical waves. And when we say mechanical, it means again I will be writing medium dependent. Sound cannot be transmitted through vacuum. Sound cannot be produced in vacuum. Why so? Because sound is produced by the vibrations in the medium. And when we talk about vacuum, there is an empty space, there is no particle, there are no particles, so nothing to vibrate, no sound will be generated, and even no sound will be transferring from one place to the other place. Actually, these vibrations, they are carrying the sound from one place to the other place. So mechanical waves are the waves which need medium to propagate. You can even say to move on. Propagate means to move on. You can have sound waves or longitudinal waves. Already we discussed the definition, the waves in which oscillations are in the same direction. Theta is equal to 0 degree in the direction as the direction of travel of wave or energy. Here I wrote already. So example of sound wave, a longitudinal waves is sound waves. Now, just like transverse waves are consisting of crest and trough, longitudinal waves, they are consisting of compressions and rarefactions. Compressions and compressions and rarefactions. Now, my dear friends, what are compression? These are the places where the particles are closer together. You can see if this is a spring, it is a slinky spring, means soft spring. At compression, the particles are closely packed. Then next to compression, there will be a rarefaction. Then again compression. Okay, what is rarefaction? This is the point or place where the particles are pushed further apart. Again compression, then rarefaction, compression, rarefaction. So sound waves are traveling in the form of compression and rarefaction. They will not be asking you to mark the amplitude of longitudinal wave, which are also, because of compression, they are also known as compressional wave. I wrote it on previous page, but better to repeat it here. Compressional waves. So sound waves are longitudinal waves. They are medium dependent. They cannot be produced in the absence of medium. They cannot be transferred. They cannot transfer energy in vacuum or in the absence of medium. So compression, rarefaction, they travel in this way. One very important thing again, compressions are the regions where the particles are pushed closer together. Rarefactions are the regions where the particles are pushed further apart. This is one way to define compression and rarefaction. Another way, the wave motion of sound resembles to that of a slinky spring. Slinky means soft, or you can, for understanding, you can say spring with low value of K, mean easy to stretch, easy to compress. So showing regions of compressions and rarefactions. Now, region of compression has a slightly higher air pressure as compared to the surrounding air pressure, while the region of rarefaction has a slightly lower air pressure as compared to the surrounding air pressure. So we can define compressions in terms of pressure, also in terms of the arrangement of the particles or molecules or the atoms. We can also define rarefaction in terms of pressure and also the arrangement of the molecules. They are pushed apart or like this. I will define compression and rarefaction also this way. Very important. Remember it what I'm going to do. Here, this is normal pressure, or let me write atmospheric pressure here, this point. Here, pressure is higher, and here I can say pressure is lower. And my dear friends, I can also show it like this. On this diagram, this upper portion, these both, they are showing the compression. Compression is a region where pressure is higher than the normal. And these 2 points, they are representing rarefaction. This is representing what? Rarefaction. So, in the central line, that is the normal pressure, or let me say the atmospheric pressure. The crust, like if in terms, this is not crust, this is compression. Why compression? Because pressure is higher than the normal. And the troughs which are shown here like troughs, they are not troughs, but they are rarefactions where the pressure is lower than the normal pressure. So remember this diagram. They may ask you to mark compression and rarefaction. Don't be fooled by the examiner that you're writing it crest and trough. See what is mentioned here. This is pressure axis, and this is time. Sorry, atmospheric pressure. So if it is mentioned, label axis is labeled as pressure, so we will not consider it in terms of crust and trough. We will consider it in terms of compressions and rarefactions. Very important thing. And now wait a minute, one thing more. Wait a minute, I will take your question, but before that, if here this is y in centimeter and here this is time in second, then my question from you all, why the figure below cannot be used to find the wavelength of the wave. I will be asking you this question. You will be answering me on Saturday. See, wavelength is in general from crust to next crust or from trough to next trough. But why this equation, this diagram cannot be used to find the wavelength of the wave? Okay, this is your one of the homework question. Now I'm over here and there is a question by somebody. They can ask you, why not your daughter? You will be asked to draw some time diagram like a 2 marks question from your question here. Ruba, I have in my mind. They said few years back there is a rope which is long enough than the wavelength of a wave. There is a rope which is long enough as compared to the wavelength of the wave. Draw a transverse wave with the help of that rope and label 2 important features of that wave. And you have a very good question. Now see if I want to answer it, I can answer your question here. Like you were given a rope like this, which is much longer. It is fixed at one end. Now this end is fixed. Then from this end, your hand holding this, moving up and down, producing the disturbance into the medium, and disturbance will be transferring, and you can do it now. Now this is a proof that this is longer than the wavelength of the wave. And he said label 2 points, 2 properties of the wave. Like I can label one property here. This one is what? We know this is amplitude. And also he can say, okay, label the wavelength. So my dear friends, from here till here, he did not say label the wavelength. He said discuss or label 2 properties of the wave. So one is Amplitude we have labeled, other one we have labeled wavelength. Okay, so yes, they will ask you to draw it. No, it's not necessary that they will not be asking you to draw it. Okay, now next is, so one thing more before I move forward, one thing very important: compressions and rarefactions. They can be defined in terms of pressure. They can also be defined in terms of particles arrangement. So in exams, if there is no restriction, no limitation, you can write any definition. But sometimes they are giving the keyword that define compression in terms of particles. So then the definition of compression will be: compression is a region on a wave. It should be longitudinal wave. I'm just writing on a wave, where if he said particle, you will use the term particles. If he said molecules, you will use the term molecule. Is a region on a wave where particles are pushed closer together. Where particles are pushed closer together. Similarly, rarefaction. Rarefaction is a region particles are moved further apart. So not only in terms of pressure, my dear friends, you must be knowing in terms of arrangement of the particles or molecules or atoms. Now, sound waves are produced by vibrating objects. As I told you, sound waves are produced by vibrations. We cannot observe them in general, but by with little effort you can see them. Like, put the saucepan in the kitchen upside down, such that its base is pointed upward. Take few pieces of paper, put them on the base, on the top of that saucepan or cooking pan, whatever you want to say, and then take one spoon and hit the spoon on the surface of the saucepan. Sound will be generated, and also you will find that the papers are moving, they are vibrating. So why the papers are vibrating? Before they were not vibrating. When you are hitting the surface of the cooking pan or saucepan or container, so there are vibrations into the container body. So those vibrations are carrying the energy and you can hear the sound, but you can see those papers are almost vibrating on their place. That's why in the beginning today I said that vibrations are parallel to the direction of travel of energy, longitudinal wave. If the vibrations are perpendicular to the direction of travel of energy, transverse waves. So waves can transfer energy without transferring the matter. Very important, remember it. So whenever this line is not it is a very short line, because I am not believing in doing a lot of explanation such that you are not understanding too much. To the point, required according to the syllabus explanations, and then focusing on past papers. So vibrating objects will generate sound waves in a medium. If no medium, it means no particles are there. It means vibrations are not there, because vibrations are within the particles. So neither the sound will be generated nor it will be carried from one place to the other place if there is no medium. And what do we mean by medium? It means, medium means solid, liquid and gas. I will share with you inshallah next class one question where we will be solving a question based when there is a bell jar and having air inside. We will discuss. So I will just put the paper in front of you, open it in front of you, and we will solve. So I am just writing here for a hint: bell jar experiment. Bell jar experiment question mark. Here we will discuss. Okay. Now, transmission medium for sound. any medium with vibrating particles can transmit sound, can transfer sound, and sound is a form of energy. The more closely packed the particles, the faster the speed of transmission of sound. The faster the speed of transmission of sound. That's why sound travels fastest in solids. On the average, it is 5,000 meters per second, and you have to memorize this numerical value for solids. Followed by liquid, because particles are packed not like the solids. 1500 meters per second, this is the speed of sound in liquids, and slowest in gases from 300 to 350 meters per second, any number you can say. And this is in what? This is in gases, this is in liquids, and this is in solids. These all three numerical values you have to memorize, and this is so important. This is so important. Again, first of all, medium is needed. Sound waves are longitudinal waves, and sound waves are medium dependent. That's why we call them mechanical waves. If the particles of the medium are tightly packed like the solids, so the vibrations are transferred very quickly, let me say within no time. We all teachers are saying within no time. Means it takes time but very short. So speed is fastest. So solids, especially in metals, the speed of sound is fastest, and you must be remembering this numerical value. On the average for the speed of sound in solids, that is 5,000 meters per second. Sound is also heard in the speed of sound is in liquids is less than solids but more than in gases. So in liquids like water or other liquids, on the average the speed of sound is 1500 meters per second, and it is slowest in gases because particles are furthest apart, so the vibrations or the disturbances are carried from particle to particle in more time, so speed is less. But this is Cambridge, not only to memorize this will be there in MCQ, this will be there in paper 4, but they are asking some very technical questions. Now listen the question carefully. I will give you an example. Let's suppose we are at 28th floor of a hotel, and this you can definitely easily experience in Makkah. We can easily experience this in Makkah. I still remember with my parents, 1.5 years back in Makkah, we were there in Kiswa Tower Hotel, and we were on 28th floor. Okay, so just now let's suppose Sharfuddin, my friend, and Muhammad Hisham, and I'm sure both of them are active and attentive with me in the lesson. They are going to do this experiment. Listen to me carefully what I'm going to share with you people right now. Let's suppose the lift elevator of the hotel is not working properly, and one or two lifts are working, and there is a lot of crowd. Mean it is prayer time or Juma prayer time, something like that. So very crowded. So there is always stairs. There are always stairs from one floor to the second, and second to the third, and so on. Now Sharfuddin is at floor 5. Holding a hammer, and Muhammad Hisham is at floor 3. Now what they are doing, Sharfuddin is telling him ready, and Muhammad Hisham is ready. Sharfuddin is hitting the hammer to the metal railing of the staircase. You know, staircase, one side is wall, other side there is either wood or metal railing. We can hold and climb up. Anyhow, so he hit the metal railing, you can say, or metal grill of the staircase. He is hitting it with the hammer once, and Muhammad Hisham is keeping his ear. Muhammad Hisham is doing what? He is keeping his, one moment, why I'm not there? What's this? Okay, my dear friends. Now, so Sharfuddin, he hit the hammer on the metal grill once like this, and Muhammad Hisham keeping his ear on the grill at floor 3. He will hear two sounds with a difference of time. Please listen again. Muhammad Hisham will hit the hammer to the metal railing or grill beside the staircase once. Sound is produced. But Muhammad Hisham at floor 3, this hitting is done at floor 5. Muhammad Hisham at floor 3 will put his ear on the metal grill and he will hear two sounds. Even Sharfuddin had hit the grill only once. Why so? What is there actually? My dear friends, when Sharfuddin had hit the metal grill, metal railing, vibrations are generated into the metal and also into the air. Muhammad Hisham now at floor 3, he had heard the first sound through the grill because that is solid. It transfers the vibrations, it transfers the disturbances very quickly. And then with a margin of second, fraction of a second, he will hear another sound that will be through air because it will be traveling slowly because speed of sound in gases is from 300 to 350 meters per second. Whereas why did he hear the sound first through the railing? That was solid, and in solids the speed of sound is almost 5,000 meters per second, and it is believed that almost the speed of sound in solids is 16 times faster than in gases. So this question they are asking one way or the other way. Like many times they will ask this question like that, you are there on the ground, your car is parked in the parking, and all of a sudden there is a explosion maybe 1 kilometer away from you. So as a result of that distant explosion, you will first hear the ground tremor. What do I mean by tremor? First you will hear the ground tremor. You can say ground will be trembling like earthquake little bit, and after almost 3 seconds you will hear, or almost after a fraction of second or some time, you will hear the sound. Why it is so? When the explosion took place on the ground, so the shock waves through the solid, they are traveling very fast. Particles are packed in solid like ground, and also vibrations are there in the air, and those vibrations will be traveled slowly. So that's why as a result of distant explosion, first we people are feeling the ground tremor, 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 and then we are hearing the sound. So remember this, one way or the other way they will ask. Like most common question is that there are two technicians and they are checking the strength of a railway track, which is made up of steel in general or some alloys, metal alloys. To check the strength of that steel or railway track, one technician is holding the hammer, other technician is with some hearing tools. So first technician one hits the railway track, hit it hard once, and at a distance of 100 meters or 200 meters, technician 2 is hearing the sound. Technician 2 is what? He is hearing the sound. He will hear again two sounds. Why so? So you have to explain it that the first, when the technician 1 is hitting the railway track, so vibrations are generated through the steel and also through the air. Through the steel, vibrations are transferred quickly. So first he is hearing the sound through the steel, and then second sound after some time he is hearing through the air. So this time difference should be always in your mind. This time difference should be there always in your mind. 2 marks, 3 marks, in MCQs 1 mark. Even once it came, 3 marks, not more than this. But you must have this idea. Don't feel that they are very, very difficult. They are easy. Not a big issue. Now, my dear students, let's talk about just give me a moment. Okay, my dear friends, now few questions I will be discussing with you. Most of them I will be giving as homework to you people. Let's start here. Like, let's start from here. The diagram shows a wave. Which labeled distance is the wavelength? I need 5 minutes extra today. Maybe we will finish at 7 or 5. Just wait. Sit with sabr. The drawing shows a wave. Which labeled distance is the wavelength? A is amplitude. D is 2 times amplitude. It is either B or C. Which answer is there? Alvira, Mahdi, both of you are correct. Alhaj, okay. Sorry, this Roba, Jude is okay. Answer is C. Why answer is C? La. 2 students said B. No B. C. Wavelength, length of one complete wave. It is consisting of one crust and one trough. See, this is one trough and this is one crust. So C. This is the wavelength. One complete wavelength. Answer is C. Please, the students who have said it B, not correct. It is C. Then next, like this question. A navigation buoy floating on the sea oscillates up and down as a wave passes. In exactly 2 minutes, time is given. 6 complete wavelengths pass the buoy. So number of waves are 6. What is the frequency of the wave? Today we discussed frequency is equal to number of waves per unit time. Yes, most of you will say C and C is wrong. You will come to know now why C is wrong. Mahdi, Umar, Alvira, both of you are correct. Number of waves, how many? 6. Time, 2 minutes, but not 2 minutes. Seconds. Minutes will be converted to seconds, and on simplification, 0.05 hertz. So it means correct answer is A. Ruba, correct. Okay. Now let's move forward. Sound waves of frequency 2 kilohertz. Frequency is there. Travel through a substance at a speed of 800 meters. What is the wavelength of the wave? Wavelength means lambda, inverted Y. Speed is okay, frequency is not okay. 2 kilohertz. So it means 2 times 1000. So V is equal to F lambda. This is the equation which we discussed today. Lambda will be equal to V over F. So lambda will be equal to 800 over 2000 and answer will be A, which is 0.40 meters. Here also most of the students will get answer C, which is wrong. Not possible. It is kilohertz. Kilo means 1000. It must be converted to hertz first. Okay. Now homework questions will start. Like here, a sound wave travels through air as a series of compressions and rarefactions. Which row correctly compares the air pressure in the compression and the air pressure in a rarefaction to the air pressure nearby where there is no sound wave. Compression air pressure is higher, rarefaction, so C and D wrong. In rarefaction pressure is lower, answer is B. So the basic definitions, yes, Mahdi Umar correct, Ahmad Abdu correct. Now the homework story will start and you people will be marking I will be marking the homework for you people. Many questions will be there, so you will be solving them. Yes, like starting with question 42. So 2711. Speed through, you will solve it, otherwise I will explain you then. A sound wave is traveling through water. Today we discussed speed of sound in water. Choose correct answer. V is equal to F lambda. You need frequency here. Speed is given. Wavelength is given, so you can easily calculate. What is the amplitude of the wave? V is equal to F lambda. Frequency given. Wavelength given. What is the speed? Speed of sound. See, ice, it means solid, liquid, steam is gas. One way or the other way, they have many ways to ask you question. Again, V is equal to F lambda here. Here also see what is the amplitude, what is the wavelength. Numerical values are given. (711) here also. Yes, so nice question. What a way of thinking. Shortest time, it means speed should be fastest to travel from speaker to microphone. So how it will be fastest? You have to choose the materials. Very good question. What is amplitude and what is frequency? Okay, now rest of the things later. So our homework is up to here. Stay blessed all of you, my dear friends.